Good morning, good afternoon, good evening, everyone. Thank you for joining us from around the world for another episode of CSM Explained. If this is your first time joining us, we welcome you. Perhaps you'd like to go back to our website, not now, please stay for the presentation, but at your leisure, please go back to our website in the archive of the CSM Explained, because at that location you can download and watch some other CSM Explained webinars where we talk about the importance of having the appropriate safety systems built into your measurement chain for high voltage applications, such as those found in e-mobility applications. We also talk about some of the challenges and new technologies that have emerged associated with measuring voltage and current and the changes of even temperature measurement as they apply into e-mobility. But today what we're going to be doing is bringing all of that together into an overview with the CSM tools and interoperability with Vector's hardware and software. And we call this combined solution the Vector CSM e-mobility measurement system. Again, my name is Tom Dorr. I'm in charge of marketing and business development here in North America. And I'm going to be co-presenting with Mark Jensen from Vector, and he'll introduce himself later as we get into some of the slides that he'll take us through. So again, thank you for joining us. And as a reminder, there will be a recording and a playback of this that you can share for your own reference or with your colleagues later. So let's get started here with the first activity being some of the challenges for measurement technology coming into e-mobility. And one of the first things you really have to ask, I'm sorry, I moved my slide too much. One of the first things we really need to ask ourselves as instrumentation and test engineers is really, where are the measurement points? Things have moved around the vehicle. They're no longer just in the engine box, okay? The powertrain system, the battery pack, everything is more distributed in a skateboard form or throughout the vehicle, which really leads to more decentralized and localized measurement and being able to take measurement at those various places. We also then need to really look at the ability to have highly synchronous acquisition of those physical variables, particularly when it comes to power measurement, voltage in and voltage out, and that needs to be well synchronized so that you can get that resultant product called power, electrical power measurement, and that needs to happen in multiple places throughout the vehicle. Right? Whether that's the charge system, the battery status, the power going into the powertrain, the resultant mechanical power coming out of the powertrain, even the power being consumed by other accessories and therefore reducing the vehicle powertrain efficiency, creating range per charge and eliminating that consumer anxiety. So the accurate power measurement is really important. But so is bringing in that synchronous acquisition of ECU data and other data that's on different vehicle buses, not just a measurement bus. And then we also have autonomous acquisition of all that data, processing it, storing it, and the measurement data streams all coming together. There's various measurement points, there's various ECUs, different parts of the vehicle, different buses, that all needs to come together in one central location and be able to access that and do offline subsequent analysis for continuous improvement. When we take all that together and provide all of that capability, this is the Vector CSM e-mobility measurement system in a kind of a block diagram of products, of hardware and software from Vector in the red boxes and from CSM in the blue boxes. This is all an interoperable and very cohesive solution by our two organizations in a strong partnership. And we're going to walk you through this diagram today. Let's really first start with what we call the basic measurement system. This is really getting all of those physical variables up into analysis data acquisition software. So if we zoom in on that one box a little bit here, you see some product images from CSM the breakout modules for measuring voltage and current, other high-speed data acquisition modules running on the EtherCAT bus, some of our traditional modules that you may be familiar with, like just a traditional CAN thermocouple module or a high voltage thermal module, other analog to digital modules. All of these working together on either the EtherCAT or the CAN bus, coming together into what we call the gateway. And that gateway then takes all of that data synchronized within 1 microsecond from both CAN and EtherCAT buses and presents that up to the vector software called VMeasure Expert and a library of functions called the EMobility Analyzer, created specifically for electric vehicle applications. Right? So if we look at taking that basic measurement system into an application such as an electric powertrain, we have the synchronous measurement of current and voltage, let's say between the battery or a battery simulator if you're on a test bench, and to the inverter. So you would install a high voltage breakout module here to take measurement in a single module directly in the power cables of current and voltage. Okay. Then we also need to know if that's the power into the powertrain, what is mechanical power out. We would then use a CAN-based counter module for the acquisition of speed and torque. Okay. In parallel, we might want to know where some of our efficiencies of the system that are generating heat and heat losses, and so we would measure in parallel temperatures inside the electronics, inside the inverter, what's happening inside the motor at certain locations, even some capabilities of putting those sensors directly into copper windings in the motors and stators, and really getting accurate temperature measurements. Here we're showing the PT or platinum based resistive thermal devices that could also be thermocouple modules, whatever the right type of sensor for your measurement application is, and being able to also take those measurements inside the high voltage electronics. So then we can look at the calculation of efficiency in the powertrain in real time. We now have electrical power into the system, mechanical power coming out of the system. And that's really done by taking that high speed sampling rate of up to 1,000 kilohertz of current and voltage, putting that on the EtherCAT bus. Temperatures aren't so fast. We don't need such high speed sampling rates of the speed and torque at the wheel end, so those could be on a CAN bus, but we bring all of that together into this gateway. And that gateway then can do the high synchronization of up to 1 microsecond using the precision time protocol of IEEE 1588 time synchronization. And while we show in the example here of just bringing in one EtherCAT bus from one breakout module, there are different variants of these gateways where you could even bring in 4 high-speed EtherCAT buses, 2 CAN buses, maybe one of them is a measurement bus, one of them's a vehicle bus, or maybe you have such high channel count that you or bandwidth that you have 2 different measurement buses. You can bring that together into this single gateway, and then that all connects to the PC through one Ethernet port, and presenting all of that data through XCP on Ethernet to the software, and that's where all of the power and subsequent analysis is done. And that software is VMeasure Expert from Vector. And at this point, I'd like to introduce Mark Jensen to take us through not just the VMeasure Expert and software, but the other Vector tools that are part of the overall measurement system. So Mark, thanks for joining us today. We really appreciate the coordination and cooperation here in presenting our joint solution. Thank you.
Thanks, Tom. My pleasure to be here. Thanks to all of you for taking time out of your day. to spend a little bit of time with us and learn about our joint CSM vector solutions here. So the tool that Tom correctly pointed us to here is VMeasure Expert, and that is our tool for data acquisition to bring in data from many different sources. Certainly our CSM measurement modules that we're here to focus on today, but also definitely to include vehicle buses, as you would typically expect from Vector, to get ECU internal data right out of the ECU RAM while it is running, from video or GPS inputs, and then to bring all of that data in real time and perform live real-time calculations on that data to get analytical outputs while the measurement is running, so that we can log the analysis in parallel with the live data. The key feature for us today in e-mobility applications inside of VMeasure is what we call the EMobility Analyzer. Tom referred to that in the initial slide and showed it as a block at the top of our diagram here. This is a standard feature that is built into the VMeasure product, and it's a function library designed to do the typical kinds of calculations to analyze the performance of an e-mobility electric motor powertrain system. So we have the high voltage needs, we have the electric motor, especially for three-phase motor analysis. We have the ability to analyze the individual signals and to really get into the nitty-gritty that is really key to understanding and fine-tuning an e-mobility system. These functions inside of the e-mobility analyzer are written specifically for use with the CSM measurement modules. They are fine-tuned to work exactly with the high speed, high sample rate data coming out of the CSM hardware. And Tom referred to that earlier on, and we'll talk a little bit more about this in detail. So this is really a crucial point where our two companies, CSM and Vector, have come together to produce a harmonized solution. Here we see an example of an e-motor power analysis function from the e-mobility analyzer function library. Here's the analytical algorithm is right in here, and on the left side we connect into it the inputs that are the three voltages and currents from our three-phase motor, and then coming out of it is this package of signals that indicates things like power in real time and reactive power and apparent power, and we can look at maximum voltage and maximum currents and things like that. And this is all running live inside of the measurement. So even at these 1 kilohertz sample rates of the voltages and currents that are inputting, this algorithm is running in real time at that same 1 kilohertz. I'm sorry, 1 kilohertz measurement rate, and we're getting lots and lots of output coming out from that very quickly. The e-mobility analyzer is also found in our Canopy tool. Canopy would be of interest for you if you have not just measurement but also calibration needs inside of your application. Canopy can cover both the measurement and calibration needs together in a single tool with a single interface, so no need to have separate tools for measurement and calibration. We can bring it all together inside of Canopy together. So let's revisit our measurement system. We're all set up here with our physical measurements. We have the voltages and currents going between the battery and the inverter. We have the temperature inside the inverter. We have the temperature inside the electric motor, and we have the measurement of the mechanical output to the wheel. And all of this comes together into the XCP gateway over EtherCAT or CAN, depending on the type of signal we have. And then that's packaged up very nicely into an XCP on Ethernet stream through a single Ethernet line that comes up to our measurement PC where the VMeasure tool is running. But To go past that, we had indicated we need to also measure data from inside of the ECUs while they're running, as well as data off of the vehicle communication buses. To do that, we're going to bring in some additional vector hardware. To look at the vehicle communication buses, we're going to look at hardware from the Vector VN family, the Vector Network Interface hardware family. And to get our data from inside of the ECU, we're going to look at the VX family, which connects directly to the debug port on the ECU microcontroller on the development ECU's PCB. So we're going to poke directly into the memory of the ECU while it's running so that we can read measurement signals right out of the ECU RAM. So let's start out by inserting a VX system into our measurement setup here. And we'll insert a VX1000 base module right here in the middle of the system. And directly connected to that base module is a plug-on device, or a pod, which is the small component that connects onto the debug port on the ECU PCB and allows us to look into the ECU RAM while the ECU is running. And we can measure the software variables at a very, very high rate and bring those in and bring them into the VX base module. But also with that, we can take all of the output coming from the XCP gateway and bring that into the VX base module as well. And using the precision time protocol that Tom referenced before, we can time align very precisely all of the data from the XCP gateway, all of the data from the pod, and put it together on a single Ethernet connection back up to the measurement PC where VMeasure is running. There's a lot of different hardware variants in the VX family, and the reason for this is there are a lot of microcontroller and debug port combinations out there, and depending on your particular application, there is bound to be a VX1000 hardware configuration that's right for your microcontroller, debug port, and measurement data rate requirements. So we've got our VX1000 system situated in, and now we have combined physical measurement and ECU internal data measurement going on simultaneously. But we also said we wanted to be able to look at data that's on the vehicle communication buses. And to do that, we're going to bring in more vector hardware from the VN family for vector network interfaces. So on one side of the VN box, we're going to connect up to the communication networks in the vehicle. And whether you have CAN or CAN-FD or LIN or FlexRay or Ethernet, we've got solutions in the VN family for that. And then we'll take another Ethernet connection from the VN interface, bring it into the VX1000 base module, and then all of the vehicle communication bus data will be incorporated into that same single Ethernet line that comes up from the VX1000 base module to the measurement PC where VMeasure is running. And then again, using that precision time protocol, we have time alignment between the vehicle bus data, the ECU internal data, and the physical measurement data from all three sources coming together through the VX1000 base module. And now we've got a single clock in VMeasure Expert that is time stamping all of the data and presenting it in a perfectly time synchronized way and logging it that way too. So as I said, the VN family comes in a lot of different form factors. So depending on what kind of channels you need, what your channel counts are, and whether you need a standalone module based on USB Ethernet or a built-in module that goes inside of a rack, we've got different VN hardware options for you there. So now we've got a complete measurement system, and this looks like a very, very nice setup to run on the bench, and we've got all of the data we want coming together, and we're in pretty good shape. But we indicated at the start of the discussion today that we also want to be able to log all of this data automatically in the vehicle. We don't want to have a laptop open on the passenger seat or an engineer riding in the vehicle while it's out on the test drive. We just want to be able to automatically log and save all of that data while the vehicle is out on the road running a test drive with no human babysitter overseeing what's going on. How can we do that? Well, let's go back to our measurement system here from the bench and focus now on the measurement PC that's up here at the top. Wouldn't it be great if we could just replace that with a data logger, leave all of this other stuff in place exactly as it is, with all of the measurement configurations that are on them in place, not have to change anything, just swap out this top level node, our measurement PC, with a data logger. And to do that, we can bring in a Vector Smart Logger. And what's shown here is the Vector VP7440 Smart Logger, which is running a different version of the VMeasure software called VMeasure Log. VMeasure Log is all of the same data acquisition and analytical capabilities built into a tool that's designed to run headless on an automated logger in the vehicle with no human engineer starting the measurement, ending the measurement, setting it up. It takes exactly the VMeasure Expert measurement configuration we had on the bench. It takes that exact same configuration and runs it again on this automated logging system, which begins logging at the start of the drive, ends logging at the end of the drive, captures specific events as they occur, and we're in great shape having an automated logger here. To check on the status of the logger, the VMeasure Log tool provides a web interface, and through a Wi-Fi connection, we can have a smart device like a smartphone or a tablet or a PC, anything with a web browser on it. We can connect through Wi-Fi to the smart logger and check on the status of the logger. Is the logger running? How much free space do we have left on the RAID storage pack? How much data are we currently connected to, and how much data is coming in, and how long is our storage pack going to last before it's full, and all of these kinds of things that we'd want to check on to make sure that the logger is doing its job properly. So now we've taken our benchtop test system, brought it into the vehicle, packaged it up in an automated logging system, and we're ready to hit the road. But once we're out on the road and we start running test drives, or whether we're still on the bench and running bench tests, we're going to start to accumulate a lot of data. And maybe we've even got a whole fleet of test vehicles out there generating log files, and it won't be too long before we are overwhelmed with all of this data, and we're going to need some tools to help ourselves manage and analyze that data after it has been collected. To address this challenge, we've got two products from Vector, vSignalizer and VMDM, that are going to help us out with this situation. To start with, vSignalizer is a really nice tool to complement VMeasure. vSignalizer doesn't do any communication. It doesn't connect up to anything to do data acquisition. It simply allows you to visualize and analyze all of the log files captured with VMeasure Expert or VMeasure Log, and it can show them to you graphically. It can process them to generate metrics. It can mine many data files across many tests, many drives, many vehicles to look for occurrences of interesting events, to extract metrics, to generate reports that can be shared in PDF or email or PowerPoint for people who don't have these analytical tools. And it's there to provide that perfect analytical complement to VMeasure once you have all of that data collected. How do we manage the store of data that is being generated by all of these tests? VMDM, the Vector Measurement Data Management System, is here to help us with this. This is a server-based or cloud-based solution where the data from VMeasure Expert or VMeasure Log is automatically uploaded into the server or into the cloud, where it is captured and indexed, and data signals are classified, and the data is made globally available to all of the end users who want to run a tool like vSignalizer or Canopy to do data mining runs or to generate reports and so on. So VMDM is that high-level data management warehouse that automates the indexing and classification of the data and can automate data mining and report generation, but gives you global access to all of your data without having to make copies of the data. It provides it globally out to anybody who wants to do on-demand analysis with vSignalizer or Canopy. So that's the vector side of the story here. And what we have not touched on is the CSM companion to the vector data logger concept, and that's the Unican data loggers from CSM. And I'll turn it back over to Tom, and he can walk us through those products.
Thanks, Mark. Again, really appreciate your contribution to this. The vector tools, interfaces, and software is such an integral part of this overall system that we can provide to our customers for, again, a complete solution from sensor tip all the way to numerous consumers of that data throughout an organization for optimizing designs and releasing new electric vehicles. So as we have on the screen here now, the Unican 3 data logger, actually we've made a decision here. We're going to do a whole separate CSM Explained session just to save time here on the CSM logger. We'll have a separate session in that, so please stay tuned for future announcements as we schedule that session. So really moving to again the overall view, you can see again vector tools, hardware and software in the red boxes, interfacing and interoperable with the CSM tools in the blue, and that comprises the overall e-mobility measurement system. Just want to summarize here and wrap up that again, the measurement points and locations are increasing as we move to electric vehicles, especially in those high voltage locations for temperatures, strains, vibrations, current, voltages, the list goes on, and those are more distributed around the vehicle than they are traditionally in an internal combustion engine architecture. And so the CSM tools really lend themselves well to that with the small mini modules and IP67 capability. That's the extremely compact, easy to package around the vehicle. Then the gateways and bringing in the interfaces through the VN and VX family of bringing all that synchronous data, whether it's measurement data, vehicle bus data, ECU data, all coming into one central feed into that multi-channel real-time power analysis as available in VMeasure Expert software with the EMobility Analyzer library of functions there, and capturing all that raw data, recording, very powerful, and having all that data available either in the laptop or the VP Smart Logger from Vector. So we'd like to further discuss with you your specific application needs. We focused on powertrain, but there's overall vehicle efficiency. There is also, just numerous applications associated with electric vehicles on the charging side of the system, overall vehicle efficiencies, specific consumer, if you will, cannibalization of the power available from the battery to sacrifice from the powertrain. The list goes on, and you can read some of those use cases on our website as well. So while we have a very powerful solution, we're very proud of this. Would certainly love to talk to you about your application. We're not resting on our laurels. Between CSM and Vector, there's always continuous improvement and expanded applications that we're going to be bringing to market. Even if you have something that's quite unique. We can work with you in customer-specific development. And all of the software that you're seeing here has been the CSM business model with our CSM config software. If you have the right licenses from Vector for VMeasure Expert, these software and analysis tools are going to be continued to be available within each Vector release. It's really part of our core business operations now of making sure that that your investment in our tools continues to grow as new innovations come about. So yeah, we're really not resting on our laurels. Either the two organizations with what we've brought to market today. This will continue to improve, and your investment is secure as you'll get those enhancements as well. Okay. With that, that's the conclusion of the core presentation.